How you doing, guys? Welcome back to another Medic Mind GAMSAT video. My name is Harry and today we're looking at section 3 again. This time the chemistry topic of equilibria, acids and bases. So today we have a number of goals that we want to achieve. Firstly, to develop a basic strategy. If you see any questions associated with acids and bases or different chemical equations involving them, do you have a method that you're going to use to tackle those questions? Secondly, we want to revise the theory. So we know that there are a couple of basic ideas in this area that really need to be understood, particularly when it comes to looking at equations. If we understand what acids, bases, conjugates are, we'll have a really good understanding of what's in front of us. Thirdly, learning equations. Now, it's not that you have to learn complex chemistry or chemical equations for that matter, but more to have certain tricks that will really help you answer certain questions. And there are some equations that I really recommend learning associated with logs, and I'll get into that later in the video. And finally, we want to deal with the sample questions, of course. So I want to tie everything that we talk about in using sample questions. So understanding the basic theory is fundamental to this area, and I can't emphasize that enough when it comes to acid, bases, and equilibrium. Understanding how an acid works and what even the definition of an acid is. And there are a couple of definitions out there. For example, you might see it as a proton donor. And then you talk about bases, a proton acceptor, for example, and how then they act in a solution and also how they can change and move. And also other concepts that we will get into later, such as Le Chatelier's principle, and how these different compounds interacting in dynamic equilibrium, how does that change with time? So, as I just mentioned, when it comes to acids and bases, we need to understand a couple of ideas, not just from the point of view of what's the definition of an acid or what's the definition of a base, but also, again, when it comes to solutions and when it comes to acids and bases and the equilibrium, we need to understand how dynamically different things are at play here. And first of all, that involves the terminology. If I talk about an acid or I talk about a conjugate acid, do you know the difference between those things? Equations. Do we understand, for example, if it's a reversible reaction? And do we understand how the equation will flow if I change the amounts of things involved in the equation? Which way will the equation move? And stress response, that also ties in with what I've just said. If I add or essentially remove certain compounds, how is that going to affect the direction of movement of this equation, and at what point will we reach equilibrium? And finally, logs. This is really important for chemistry, but not only for this topic. You're going to see it come up in various different areas, especially in the science section. For example, you may have come across it in certain graphs, even in the physics areas or biology for that matter. And so it's really important to understand logs. Also, given that you don't have the use of a calculator, logs are really, really important to have an understanding of. And sometimes they're not as conceptually intuitive of something like basic arithmetic or multiplication, division, subtraction. Those things are very straightforward and you can get them in your head straight away, but logs can be a little bit tricky. But if you understand the rules of logs, there's an example of a question we're going to go through in a couple of moments that really kind of shows you why understanding logs, and particularly the rules associated with it, will speed up some of your questions in science, even if it is related to chemistry, and even particularly if it's related to this topic and pH and things like that often employ the use of logs. So as I say, there are a number of things that you really need to brush up on in order to have a good grasp of this topic in general. So your definitions, your acids, your bases, your proton donors, your proton acceptors, things like pH curves and titrations, right? So how pH might change with respect to the environment that you're in. Chemical equilibria. Obviously, equilibrium is really important, and how that can change is the next point there, which is of course Le Chatelier's principle, a really, really important idea about how when we have a stress, we have a response to it. So essentially, if we add something to a solution, there might be dynamic movement in order to restore equilibrium. So often these equations are looking to maintain equilibrium. And so Le Chatelier's principle is definitely something you need to look over. And finally, the maths. I will emphasize throughout this video that logs are absolutely essential to this topic. You need to take the time to understand it, not just by looking at videos. Of course, this will hopefully be very helpful to you, but also taking the time to do some repetitions of your own to get quick at that kind of arithmetic that you won't have the use of a calculator for. So as I say, take the time to brush up on those kind of basic ideas to help you answer some of the questions that you're going to see in your sample papers. I'm also going to go through some questions now and incorporate a lot of these ideas to really try and emphasize the importance of these concepts when it comes to acid, bases and equilibrium. So straight into the questions. Question 1, it's asking here, if I add more hypochlorite ions to the solution, what will the impact on hypochlorous acid be? Now again, it's not always going to be the case in the GAMSAT that you need to know every single chemical compound and ions and things like that. But again, this is useful to try and help you get an understanding and also to give you the opportunity to test yourself on how much you've learned. So I'm going to give you a couple of moments to think about that question, have a go at it, and then we'll tackle it together. Okay guys, so hopefully you've had a chance to tackle that question there. So let's think about what we are given and what we've been asked. So we've been asked about two important things. We've been asked about hypochlorite ions. If we're adding those to the solution, how is that going to impact the hypochlorous acid? Well, first of all, do we understand what is going on here? Well, first of all, the hypochlorite ions, just for clarification, are of course here. And that means they're on the right-hand side of the equation, whereas the hypochlorous acid is on the left-hand side of the equation. Now, again, if you've studied Le Chatelier's principle, you'll know that this is going to involve a stress response. We want to restore equilibrium, right? Normally, if you see a two-directional arrow here, it's often the case that you will have some sort of equilibrium. So at some point, the concentrations are not important right now, but at some point, this equation is going to reach an equilibrium such that it is essentially maintaining a certain amount of each of these things, and it maintains those levels. So even though it might be dynamically moving, the relative amount of each thing is constant. However, if I disrupt that, like in this case, we've added hypochlorite ions, I'm now going to move the direction of this to restore that equilibrium. And in order to do that, I need to reduce the amount of this hypochlorite ions, and I do that by shifting the equation this way. And so what does that mean for our answer? Well, if I add hypochlorite ions, what's the impact on hypochlorous acid? Hypochlorous acid is on the left and we've added something on the right. We're shifting to restore equilibrium according to Le Chatelier, and therefore I'm going to, of course, increase the amount of hypochlorous acid. And indeed, that's our answer. So jumping straight into question number 2 now. What would the addition of more H2O to the solution be? Now I'm going to give you a moment to think about this question. Pause the video now and we'll try it in a moment. So again, this is really testing the same idea. Do you understand Le Chatelier's principle and what's going to happen? In this case, of course, we've got our water here. So we're going to add more water to the solution. This time, all we're doing is we're shifting it the other way. We're adding something on the left. We want to restore equilibrium. So we now need to shift to the right in order to use up more of that water to restore the levels that we required in the first place. So what does that mean? Well, it means a couple of things. If we look at the answer at A, for example, increased hydronium. This is the hydronium ion. So that makes sense. Increased hypochlorite, that's here. That makes sense because we should be increasing the things on the right-hand side. And decreased hypochlorous acid. Well, yes, that also makes sense because if we shift towards the right, we shift the dynamic equilibrium towards the right in order to use more of the H2O that's now available. We're also using the hypochlorous acid because the two of those is what's making the things on the right. And so we are using both of them. And therefore that would be decreased. And so it makes sense that our answer here would be A. And indeed it is. So there's two questions to hopefully emphasize the importance of Le Chatelier's principle in terms of these dynamic equilibrium and these equations that are really, really important when it comes to acids and bases. So this is a top tip. I've been talking about Le Chatelier and I'm going to continue to do that. When you experience, or a system experiences disturbance, it will respond to restore a new equilibrium state, right? So it's responding, it's reacting to what things are being either removed or added to a particular equation. If you haven't gone over that, Le Chatelier's principle, it is a really important concept. I would definitely have a look at it. Those questions there are definitely for you to come back to if you haven't already looked at Chatelier, just to test your knowledge and your understanding of that. It's a very basic concept, but it's something that you just need to have in the back of your head when you're thinking about these equations. Okay, so question number 3 then. So if you were informed that hypochlorous acid is measured to have a Kb equal to 3.2 by 10 to the minus 18, what would this mean? So here we're testing your knowledge on Kb, and Ka for that matter is also kind of associated here. So take a moment to think about this question and think about the theory that's involved. So hopefully you've had a chance to take a look at that question and have a go at it. So just to give you an overview, and I then recommend going back over this as well, there are things called the acid dissociation constant and the base dissociation constant. And in this case, we're talking about Kb. And Kb, just to clarify with you, Kb is the base dissociation constant. And the way I like to think of this, along with Ka, which is the acid dissociation constant, I think of these as the strength of a base, in the case of Kb, or the strength of an acid in Ka. So if you have a very, very small value for your Kb, a very small, now here it's 10 to the minus 18, so it is extremely small, then you're typically looking at something that is a very, very, very weak base. Now, in the case of Ka, often you'll see things maybe as low as 10 to the minus 14. So 10 to the minus 18 is extremely small. And it's so much so that effectively, this is Kb, or sort of the strength of this base, it is so weak that is actually a strong acid in effect. And the understanding of that really comes from Kb, Ka, and how the strength, how you can look at the different strengths of acids and bases. And one other thing to know is that, and I've brought up the answer there, strong acid, it is indeed a strong acid. But one thing to point out as well about Ka and Kb is that also, this is where logs come into it as well. Often you will see pKa or pKb, and these are the negative base 10 logarithm of the given value. And what that means is that if you have a really, really small, in our case, a really, really small, right, a very small Kb, that actually implies you'll have a large pKb. And essentially, it's just important to know that, because often there are certain calculations that you may have to do that will involve Ka or Kb. So just be aware of what they represent. But from a basic understanding, I would definitely recommend looking at those values in more detail, right? They're, as I say, it's their kind of how likely they are to dissociate. So for example, if something has, if an acid has a really, really small pKa, by the way, right? Large pKb, a large pKb means that we have a strong base, right? Its dissociation, its likelihood to accept a proton. Similarly, if you have a small pKa, then that means that it is a strong acid. And so that's just an important concept to realize, because having a pKa value that is very small, it means that the likelihood for an acid to donate a proton or donate a H+ ion is very, very high, such that we get a strong acid. So these are often like, and again, you might see pKa, you might see a Ka, you might say Kb or pKb. So just realize that first of all, those values are inverse. So you have to be careful about what you're seeing, and also what they represent. A small Kb, you might be thinking, well, a small value, maybe it's weak, but no, when you're talking about acid, a small value of pKa actually means you've got a very strong, if you have a pKa of -4, you have a very strong acid. So just be aware of what those things represent. So a common trap, as I've just mentioned there, Ka and Kb are something that will come up time and time again, and they represent their dissociation constants for acids and bases respectively. So just remind yourself of those, because they will come up in calculations and they will be mentioned when you're talking about acids and bases. They're very, very important values to consider. And do realize, as I say, that just have a basic understanding. In my head, I always interpreted them as the strength of a given acid or base, but just have a strategy for thinking about different concepts that make sure that you can recall it, and just make sure you have a basic understanding of that concept should it come up even in a paragraph associated with a question in chemistry. So moving straight on, question 4. So here it says a solution has a hydronium ion concentration of 10 to the power of 4, I believe. So 10 to the power of 4 moles. And we want to know, what is its pH? So now we're dealing with an important equation. If you know the equation, great. But either way, pause the video, have a think about how you might go about this question. Tackle it, please. And we'll try this in a moment. Okay, so hopefully you've had a chance to take a look at this question. There's one equation, essentially, that you really need to know, and I talked about equations from the beginning. There are a couple that are useful to know. This is an equation that will come up time and time again. If you study chemistry at any level, pH is really, really important. It's always associated with any question in acids and bases. It's really, really important measure of the strength of acids and bases and given solutions. And in this case here, I'm going to use green, might as well change the color. We are talking about a particular equation. So you might have seen this before, and it's the pH is equal to minus the log of the H plus ion concentration. I haven't drawn that very particularly well, but hopefully you can see that. So we've been given a concentration of 10 to the power of 4 moles. So we've been given the concentration of H plus ions, and that's actually all we need to answer the question. So minus the log. Now, the other important thing is this. Remember, if you're not given anything below the log, so if it's not specifying the base here, then it's log to the base 10, you can assume. And there's a really important log rule that I also recommend going over the log rules in general, but a particularly useful one here. And I think you should really have a look at all the log rules, because you'll see how important it is. But basically, and it makes this calculation extremely simple, right? And it is that log B to the power of K is equal to K. So it's limited in that it's not necessarily always going to come up that you have these exact values. But if you get something that is log to the base B, and then your concentration here is that same number to the power of K, to the power of whatever, then your answer is simply that power. And that's really, really important. So in this case, remember, we do have a minus, however. So in our case, we have log to the base 10 of 10 to the power of 4. So that means our answer is just 4 in this case, for representing the K. However, remember that pH is minus the log, and therefore it's minus 4. And so think about if you didn't know that logarithmic rule, think about how you might have gone about that question, or how you might have tackled it in your case when you pause the video, and realize how much quicker it is if you have the log rules down. And the other thing I can promise you is that you won't just see it in chemistry, you're going to see it in a lot of sections. So it is worth taking the time to learn these rules. And indeed, our answer there is minus 4. So take the time, look at your log rules, make sure you understand them. That maths comes up in multiple questions year in, year out. And a final top tip is, as I said about equations, you need to memorize the equation for calculating pH. It's super simple. Even in the time that we've gone through that there, hopefully it's gotten into your brain, right? pH minus the log of the H plus ion concentration. If you get that down, you are in a great place. I'm going to cut this part of the recording because this is a remember Le Chatelier's principle. which is repeating itself. So if we could just cut both that portion of the slide and also the recording. Okay, on to question number 5 of 7. In an equilibrated stoichiometric mixture of ammonia and hydrochloric acid, what would the pH be? Now, this is going to be tapping into your understanding of acids and bases, and in particular, the strength and relative strength of those. So take a moment to pause the video, think about this question, have a go at it, and we'll try it in a minute. So if you haven't come across acids and bases before, this is a bit of a tricky question, but I'm going to show you exactly what to do. So this is just testing you. It's not necessarily the exact type of question you might see in the GAMSAT, but it's good to maybe have an idea of what certain acids and common acids and bases, are, and their relative strength. So anyone that has seen HCl before knows that it is a strong acid, right? It's a strong proton donor. And ammonia is somewhat of a weak base. And so, what we want to do is, we've got, like I said, we've got an equilibrated mixture here. And the pH for that reason. So if we've got a strong acid, what's going to happen is, right, your HCl is going to donate, right? So your HCl is going to donate such that we have a H plus ion. And we also have a Cl minus ion, right? We have the chloride ion. The chloride ion is negligible. Technically, it's the conjugate base in this case, but it is of negligible kind of strength, if you will, of a base, right? Whereas again, I've accidentally tapped on the number, but I will continue to clarify. So the ammonia will accept a proton here. So this will accept a H plus and become NH4 plus. This is a weak acid, but it is less negligible, if you will, than the Cl minus, which is pretty much completely negligible as far as its base. So this is a conjugate acid, right? This is the conjugate acid of the ammonia. And such that it has the little bit of effect of drawing the pH down, while the Cl isn't really doing much. What that results in is essentially a pH that is slightly lower than 7 because it is slightly acidic. And so that's just to kind of help your understanding. And so, of course, the answer is C here. It is less than 7, right? It is a slightly acidic solution. Again, it's not super important to, it's unlikely that the GAMSAT will expect you to, look at a particular compound or and understand whether it's an acid or a base or and its relative strength. It's not necessarily expected of you, but this is really just trying to show you that you need to understand how they might interact, and also it's useful to understand some very, very popular compounds that will come up time and time again, and that they're very useful to as examples for you to kind of learn these ideas. So the second last question now. So the question says, to achieve a completely neutral pH, what would need to happen to the ammonia and hydrochloric acid mixture? So how do we achieve a neutral pH? We're below 7. We want to bring it up to 7. What do we need to do? So have a go at this question. Pause the video and we'll try this in a minute. So I mentioned that the conjugate acid of the ammonia is, of course, a weak base. But essentially counteracting that would involve what exactly? Well, we obviously don't want to add an acid. We want to add a base, or certainly something that acts like a base. And so in order to do that, we would add more ammonia. Now, why would we add more ammonia? Well, remember that ammonia is a weak base and its conjugate acid is a weak acid. And so if we add the ammonia, right, we can actually neutralize the acid itself, right? We can, in this case, we have NH4 plus, which is a weak acid. And so that's what's making it more acidic. However, if I add NH3 plus, it's a weak base. And so what needs to happen in the mixture is I need to make it more basic. I need to increase the pH. And how do I do that? I add a base. And here, what do I know? Well, I could use something like, for example, here they talk about a bicarbonate solution. That is a basic solution. However, it's the best thing if you have a conjugate acid, the best way to neutralize it is with the base, right? If you have the base and the conjugate acid, they're completely opposites. So of course, I could add the bicarb, but it won't completely neutralize it, or certainly the most appropriate way to do it is if I have the conjugate acid, I can neutralize it with the base. So I would use ammonia as the most appropriate here to add. And indeed, that's the correct answer, to add more ammonia. We don't want to, obviously we wouldn't add more hydrochloric acid. We don't want to make it more acidic. Finally, the last question here is, which of the following would have the weakest conjugate? And so this is a basic concept that you will come across time and time again. And so we're really just testing this to test your understanding of this topic. Have a quick go at this. Think about acids and conjugate acids, bases, conjugate bases, and we'll try this question in a moment. Now, I should have pointed out before you tackle this question that this says strong base twice. So let's just assume that B would be a strong acid. Now, if we think about this question, which of the following would have the weakest conjugate? Well, interestingly, the stronger for example, the stronger an acid, the stronger base, right? But let's take an acid as an example. The stronger the acid, the weaker that its conjugate base will be. And the reverse is true as well, right? The stronger the base, the weaker that its conjugate acid is. And one of the things is, essentially, right, if you have a really strong acid, then it's so willing to donate a proton that there is essentially no tendency for the Cl minus. If we take that case, right, HCl so readily donates a H plus that there's essentially no tendency for the Cl minus to re-accept the H plus again, to re-accept the H plus. And so we get this kind of inverse relationship where when you have a strong acid, when we get the conjugate base, so if you take the HCl, you've got the HCl is a really strong acid, but then when it donates that H plus and you're left with your chloride ion, it's really not willing to accept at all. So it's not a very good base at all. It's extremely weak, therefore it's all but neutral. And that's a really important idea to consider. And therefore, so which of the following is the weakest conjugate? Well, a weakest conjugate is going to come from the strongest. It's not going to come from a weak base or weak acid. And indeed, it's a strong base. Again, that should probably be acid for the purpose of this question. But again, yeah, as we suspect, it's a strong base. We're thinking about how conjugates relate to their respective their conjugate, how a acid relates to its conjugate base and a base relates to its conjugate acid. So again, going over those concepts is really important. So pay attention to specific wording and make sure to read the questions properly. It's so important when it comes to acids and bases. Whether you're asked, you could be looking at things to do with weak acids, weak bases, strong bases, conjugates. There are a lot of different tricks of the trade here that come into play and will affect an equation that you might be dealing with or affect a question that you might be dealing with. And so wording is critical as ever in the GAMSAT, but particularly in areas like this where, even as I mentioned with pKa or Ka, things are very quickly changing in this area, and it's dynamic. Which is a bit cliche to say, but nonetheless true. So definitely pay attention to your questions and their phrasing. As I said, be aware that paying attention to questions, because you don't know what what they might be looking for. Straight off the bat, it mightn't be very obvious. You're going to come across questions that are really challenging for you, and so as always with the phrasing of GAMSAT, whether or not you're asked for, for example, the last question that we dealt with, dealing with strong, a strong acid is going to produce a weak conjugate base. But are they trying to trick you in the phrasing of that question? Might they say, okay, if I have a weak conjugate base, what might the strength be of the acid? And relatively, and things like that are really important to consider, the all kind of ways of thinking about it, and the different ways in which you could be asked a question about it will really help you learn the tricky concepts at times of acids and bases. So your take home points. Early in this video, I started talking about Le Chatelier and I brought it right the way through. And it's a basic idea in chemistry and in acids and bases and equilibrium, but it is fundamental to your understanding of how those equations work. And it's a really useful thing to remember, to go over, and probably the first thing that you should come back to when you're thinking about acids and bases. Understanding the equations. We brought up the equation of pH, and I also talked about the logarithmic rules that would be useful to learn. So there are a couple of equations there that are really worth considering, just for your sake, because these questions, you might be given the equation, but if you're familiar with the equation, you'll be a lot more relaxed in the exam when it comes to looking at those equations. Sometimes if you haven't seen them before, it can be quite daunting. So even if you don't necessarily learn them off, be very familiar with them. And finally, revising logs. So that ties in with what I said before. The log rules are really, really important, and logs are going to come up not just in chemistry, they're going to come up in a number of topics, and it's something that is less intuitive than the other maths you'll see in GAMSAT. So learning your logs is really important, really important. So guys, that is the lesson complete. Thank you so much for joining me on this one. I hope to see you guys again next time, and hopefully this video was really useful to you. Thank you so much. See you again. Are you sitting the GAMSAT and want to improve your score? Click below and check out the Medic Mind GAMSAT online course. You'll get access to over 15 hours of GAMSAT tutorials covering all the material that you need to maximize your score. Don't miss out on this incredible offer. Click below and get instant access to the course.